discuss the analysis of the doubly reinforced beam. In this, as in earlier lectures, we discussed about the analysis and designing of the singly reinforcement beam. So today we will discuss the analysis of beam, and after that we will talking about the design of the doubly reinforced beam. So analysis of beam, I already discussed with you that analysis of beam is that we know the size of the beam, and then we have to calculate that how much is the ultimate capacity or moment of resistance of that for the particular beam. So that we have to calculate. So that is the meaning of the analysis of beam. Then doubly reinforced beam. So earlier in singly reinforcement beam, we are providing the reinforcement only in the one zone of the beam, that is the tension zone. But now we will provide the reinforcement in both sides, in tension zone as well as in compression zone. So this is then that beam is known as the doubly reinforced beam. So in doubly reinforcement beam, what we have, for example, you consider that this one is the one cross section of one beam we have, and this beam is you consider as a simply supported beam. Okay, simply supported beam, this one. So in this simply supported beam, we having one neutral axis. So that neutral axis is like one imaginary line we have, so which divides this section. I already discussed this thing with you in first analysis of the singly reinforced beam. So in this one, so this is the one imaginary line which divides the section into the two zone. One is the compression zone, second one is the tension zone. As this beam is the simply supported beam, so in that what we have, we will provide the reinforcement. So because of the simply supported beam, the downside portion is in tension zone and above is in compression zone. So first we have to provide the reinforcement. So one reinforcement we have to provide. So reinforcement we will provide in the tension zone. So okay, this is the we having. So until we are providing reinforcement in the tension zone, this beam is singly reinforced beam. If we having those, if we have to provide the reinforcement in the compression zone also, so in that case, this beam is known as a doubly reinforced beam. Now first question comes that why we have to provide the doubly reinforced beam. So doubly reinforcement beam is a very simply you can understand like this, that if this load is coming, you already know the size of the beam, but if the over reinforced beam, it becomes singly reinforcement beam over reinforced. So in that case, if you take that one, so itself IS 456 not allowed you to design that beam as a over reinforced beam. That is the first case. And second case is that because of the if some restriction happens with you, that you can't increase the size of the beam, because if over reinforcement beam you have, then you have the two choices. First is that you can increase the size of the beam, then you can only provide the reinforcement in the tension zone, and then you can say this is still singly reinforced beam. But if you don't, if some kind of problem you have, spacious problem you have, architectural problem you have, you can't increase the size of the beam. So in that case, what you need to do, you have to go for the doubly reinforced beam. So in that case, you will provide the tension reinforcement and the reinforcement in the compression zone also. In that such conditions, this beam becomes doubly reinforced beam. So you can see now we have started. So you can see, as I told you, that when we are providing the reinforcement in the tension zone as well as in the compression zone, then the beam is known as the doubly reinforced beam. Okay, this is the first I tell you. Then due to some architectural consideration, size of the beam, architectural consideration, the size of the beam you can't increase. Okay, means that is restricted. So in that condition, what you will do, that in that case you have to, for this taking that one, then we will choose it. Okay, so there are two only ways in such condition. First is the over reinforced section in the singly reinforcement we have to do, but code doesn't allow us, so we can't do it, and this is also uneconomical also. At the same time, then we will go for the doubly reinforcement beam. Okay, so such kind of specific conditions we have, that we can't increase the size of the beam. So that's why whatever section size we have, in that only we have to design it. So instead of going singly reinforced beam, we will go for the doubly reinforced beam. So this is we have, and that is economical also for us in that case, as compared to the over reinforced singly reinforced beam. Then now we having the, again in this chapter, two type of problem we have, analysis and design. So analysis, in this lecture we are talking about the analysis of the beam. So what type of problem it will come? So the only single type of problem we have is analysis of, means that we have to calculate the moment of resistance. This means MU we have to calculate. So what data we have? Same data we have, whatever we having in that one, the dimensions of the section. Dimension of the section we have. So what is the size it is given to us, so how much reinforcement we have provided. So this one is a doubly reinforced beam. So in that case, what we have, we having the two reinforcement. First is the AST. First one is the AST, that is the area of steel in the tension zone, and the second one is the ASC, that is the area of steel in the compression zone. Okay, and then the material grade, what material we are providing, steel or concrete, that also we know. So this is some data we have. On the basis of that, we can calculate the moment of resistance. So now the question comes in mind that how you differentiate the analysis of the singly reinforcement beam or analysis of doubly reinforcement beam. The problem coming to you that belongs to analysis of singly reinforced beam or analysis of the doubly reinforcement beam. So in that case, only the one difference is that if the compression reinforcement is given to you, then you can consider that problem belongs to the doubly reinforced beam. If the compression reinforcement is not given, in that case you only have to consider that beam is as a tension reinforced beam. And the one second thing is that at the same time tension reinforcement beam we having sometimes the singly reinforcement beam, there is some reinforcement we will provide in the compression zone, but that reinforcement is not the compression reinforcement. That reinforcement is the hanger reinforcement, hanger bar we call, or anchor bar we call that one. Okay, to make the shear reinforcement at the location, that's why we have to provide that. So for that, that is we consider a singly reinforcement beam. Okay, so please don't be confused. There should be a clear wording. If is there that reinforcement you are providing in the compression zone, then you only have to consider that beam is the doubly reinforcement beam. If they are saying that compression in the compression zone reinforcement is providing, that is the hanging bar or the anchor bar is there, so then you have considered that that is the only singly reinforcement beam, that is not the ASC. Okay, this is we have now. So now what are the design steps? So first step we have to calculate the XU by D, or XU, that is the depth of the neutral axis. So this is the formula we have. Earlier we having the formula in the singly reinforcement B is 0.87 F by AST or 0.36 FCK BD. Now this section also comes, that is the minus FSC into ASC. So everything we have, Fy is the yield strength of the steel, AST is the area of steel in the tension zone, FCK again that is the characteristic strength of the concrete, B and D. Okay, now ASC already we know, but now this comes the FSC. This FSC we don't know. Now how we have to calculate? So this FSC, first you have to understand, this is the how much is the stress coming in the compression reinforcement, that is the FSC we have. So how we have to calculate, I will tell you in the next upcoming slide. So you can see other except the FSC, all the things is given to me in the question. Sometimes FSC is also directly given to you. If it is not given to you, then how you have to calculate, we will see that. Now second step is then we have to calculate the XU max. So XU max we already know that that depends on the grade of the steel, that what reinforcement you are providing. On the basis of that you will calculate the XU max. So XU max when you are calculating, so XU max by D, you know that on the basis of the reinforcement. For example, if you are having Fe 500, so in that case the XU max by D is the 0.46, and that all these XU max by D values is given in the code IS 456 at the page number 70. This is the second step. In third step, what we will do now, we will compare the value of XU by D or XU max by D or XU or XU max. Okay, on the basis of that we are having the three condition. So first condition is that section is the under reinforced section when XU by D is lesser than the XU max by D, and then we are calculating the MU by using this formula, ultimate moment, by using this formula. In this formula you can see FCK we know from the grade of the concrete, XU we have calculated in step number 1, D is given to me in question. Okay, again it is calculated, B is also given to me, ASC given to me, D is given to me, D dash is a effective cover to the compression reinforcement. Effective cover to the compression reinforcement. So you can easily understand. And FSC, I will tell you at the end of the design steps that how we are calculating this stress is the compression reinforcement. This is the one. Now second is the XU by D is greater than equals to XU max by D, then the section is balance section. Okay, so in that condition what we will say, we will calculate the MU by using this formula, that 0.36, this formula we have, all the things we have except this FSC. So FSC also, D dash again is the same thing, that is the effective cover to the compression reinforcement. Now what we have, you have to take care of this thing, that when we are providing the beam like doubly reinforcement beam, so compression reinforcement here, tension reinforcement here we have. So in that case what we have, the effective cover is up to this is the effective cover we have, this is compression reinforcement, and this is also the effective cover. So most of the time what we have, the effective cover for both the tension reinforcement or the compression reinforcement is same, but it is not always it is not mandatory that it will be the same, so it may be changed. Okay, that the effective cover to the tension reinforcement is the one value and effective cover to the compression reinforcement is the second value. So on the basis of that, but in the calculation wherever we are using the D dash, that D dash is the effective cover to the compression reinforcement. Okay, so we have to take care of that one. And now how we have to calculate the compression reinforcement. So this is the some values which table we have. In that we having some values in that is depends on the d dash by d. So d dash I already told you, effective cover to the compression reinforcement. Okay, and d is the effective depth. Effective depth, I hope you know, effective depth is the overall depth minus effective cover to the tension reinforcement. That is we have. So ratio we have to calculate, and the grade of the steel is given to us in the question. So on the basis of that we will have the values, and then we have to calculate. If the d by dash is not directly comes and it comes in between, then we have to do interpolation. How we have to do the interpolation? So that interpolation we will do like this, that if we having p the value a, r is the value b, we have to calculate the value for q. So this x becomes this like this. This is how we have to calculate the between any between values. Okay. For example, at d dash by d is you having you can consider like that 5. Okay, it will not come so much value, and you consider this one is the 7 it coming. Okay, and then you have to calculate that d dash by which you have calculated, that is coming 6. Okay, so for 5 you know the value, one value is there. For example, you consider that value is the 1 and this value is the 2. So now how much is this value? Then you have to calculate by using this formula. Then you will get this value. So this is the how interpolation we have to do to get the compression reinforcement. So compression reinforcement, how we have to do that? So you have to remember this table. Okay, for example, but Fe250 if there, then there is no need to worry, because directly we can understand that FSC is for that condition is the 217 Newton per mm square. This is we have. But sometimes FSC also given to in the question. If it is not given, then you have to by using this table you can calculate the stress in the compression reinforcement. Now I will take one problem in that, determine the ultimate moment of resistance. We have to calculate ultimate moment of resistance. Calculate means we have to do means mu we have to calculate. So directly comes in my mind that this problem belongs to the analysis of beam. Now which beam that becomes? So the doubly reinforced beam, it is already written that doubly reinforcement beam. Okay, then using Fe415 or M20 grade of material, then take stress level in the compression steel is the 353. So this FSC is directly given to you. This is the FSC in this question is given, and this cross section is given to you the beam. So we can see this is the ASC we have, compression zone. Okay, and this one is the AST we have. Okay, so ASC and AST is directly given to me. Okay, then size also given. B is the 250 mm. Capital D is the 500 mm is effective. This one is the 450 mm. It is also given to me, so directly I can write. But D dash is the effective over to the compression reinforcement. So effective over to the compression reinforcement is also given to me. That is the 35 mm. It is also given to me, so I can see. Now M20 grade of concrete is given, so FCK I easily get 20 Newton per mm square. Okay, Fe415 is given, so directly I can say 415 Newton per mm square, or page number 70 directly I use here. Then I can simply say that XU max by D equals to, for Fe415 is the from page number 70, if I use, that is the 0.48. So this is we have. Then FSC is also given to me, that is directly given, so no need to do any interpolation or directly given that FSC is in this case is the 353 Newton per mm square. Now I will start. So in first step what will I do? I will calculate the XU or XU by D. So all the values I am having, FSC is also given to me. If FSC is not given to me, then first step for me is to calculate the FSC by using the D dash by D and then interpolation the table, then we can calculate. So this is how we have to do. So Fy is 0.87, Fy is a 415 given to me, AST is 1620 Newton per mm square, not Newton per mm square. Fs is the 353 Newton per mm square, ASC is the 559 mm square, it is also given to me, 0.36 FCK 20, and B is the 250. So this is how I am getting. XU is the 215.32 mm. Okay, now I will calculate the limiting value. So XU max by D I already know, D I already know that 450 is given to me. So I can easily calculate the XU max. So XU max when I calculate it is coming 216. That is coming 215.32. It is coming 216. So easily I can say this section is condition is this and section is the under reinforced section. So in this case moment of resistance formula we have all the values we have in this one. So we can easily write it and easily we are getting it. So whatever value is coming in this equation, that is coming in Newton into mm. I again repeating you, please take care of the units. That's why we are writing the given data in the beginning, so that whatever problem occurs because of the units, we can address at the in the beginning itself. So please make sure that whatever unit you are getting and how it will come, so you can easily understand when you are writing the given data. Okay, now then Newton into mm, if I have to convert kilonewton into meter, I have to divide this entire value by 10 raised to power 6. 10 raised to power 6 I have to divide, then I get this unit of this one is the kilonewton into meter. This is how we have to do. Then we are getting 220.25 kilonewton into meter. This is the moment of resistance for this beam, which is having, how much is that, which is having AST is, so we can say that moment of resistance for this question is the 221.35. this is the 221.35 or 25 something, so kilonewton into meter. Okay, for what? For this section in which ASC is the 559 mm square, AST is the 1620 mm square, width is 250 mm, D is small d is the 450 mm, capital D is the 500 mm. Okay, so this is how we have to do it. Now the second problem I am having for you, in this what we have to, this is a one, what is the problem is a rectangular beam of width is having 250 mm. So this means this is the B we have, and the effective depth of 500 mm means this one is the small d. This is the small d we have. The beam is provided with tension steel, 5 bars of 28 mm diameter. So this one is the AST. Okay, compression steel we have, so in that 2 bars of the 25 mm diameter. So this compression reinforcement word is there, so directly we can say this is the ASC we have. So and the units we also take care. The effective cover we have, so effective cover, then compression reinforcement, so that is 50 mm. So we can say this is the D dash which we required if when we have to calculate the FSC, stress is the compression reinforcement. After calculate the moment of resistance, capacity of the section. Okay, so moment of resistance in analysis problem, this one M20 Fe41250. So Fe250, if you look at the table, so directly you will get it that in this, for this grade of steel, FSC, that is the compression stress in the compression reinforcement, that is always 217 Newton per mm square. So this is we have on the basis of that directly. So M20 is, that is, so FCK we are getting from here. And for the here we are getting two values, that is the Fy and second is that is the XU max by D. How much is the XU max by D for this one? For Fe250, page number 70 you have to open 0.53. This is how we have to do it. And this is the end of the analysis of the doubly reinforcement beam. Make sure that you can differentiate it while seeing that compression reinforcement is given and moment of resistance is asked to calculate. Then in that case you can understand that this problem belongs to the analysis of doubly reinforcement beam. If the compression reinforcement is not given and asking to calculate the moment of resistance in the beam, then you can easily understand that beam is the singly reinforcement beam. So this is the we having in this lecture. Thank you very much.